Hey, welcome back to Math Quest. All right, so as you can see by the title, today we're going to be solving quadratics by factoring and also using the zero product property. All right, so let's get started. Right before us is our first example. Right here we have x squared minus 13x plus 42. So the first thing you want to do is let's factor it. Okay, let's okay, here we go. I'm always thinking between the two properties. So we're going to factor it and use the zero product property to get our final answer. So here we go. What we want to do here is multiply. We want to multiply the coefficient here times this constant. So remember, in front of the x, there's always a 1. So it's 1 times 42, and that number goes up here, 42. Your middle number, that coefficient right there, goes right here. Remember that sign belongs to that number. So you're going to bring the whole thing here, and that's minus 13. Now you're going to ask yourself, hey, what two numbers can I multiply that are going to equal 42, but at the same time that I can add to also equal negative 13? So this is when knowing your multiplication tables comes in handy. And you should know that 6 times 7 is 42. So 6 times 7. So if I multiply 6 times 7, it's going to give me a positive 42, but it doesn't give me a negative 13. So that means I'm going to have to make them both negative, because negative times the negative gives me a positive. That would be positive 42. And if I add them, it gives me negative 13. Excellent. At this point, I'm pretty much done factoring. So right here, I'm going to set these up. I like to just write these out, and then I put an x in each one, right? Because that's the bottom value here, the denominator. The denominator is 1x. Remember, these are the wings here are my x's. So this is the only one that's x squared. So right here we have a minus 6. We're going to go ahead and put that in here. So minus 6. Right here we have a negative 7, and we're going to put that in here. So minus 7. All right. At this point, I am done factoring my quadratic. Now, this process also wants me to use a zero product property to find my x values. I want you to understand what you're really finding. You're finding the x value of your intercepts, your x-intercepts. Now, if I have an x-intercept, you should know by now that my y value is going to be 0, right? So here, all you have to do, let me give myself some space here so you can see better. I'm going to get the x minus 6, and I'm going to set that equal to 0. I do the same with the other one, which is x minus 7, and I'm going to set that equal to 0. Then you just solve by adding 6 to both sides. Adding 6 to both sides here and adding 7 to both sides here, right? Two different ones. So you're going to get 6, 0, because my y value is 0 when I intercept the x-axis. And then here I'm going to get 7, 0. So I just found my x-intercepts of my parabola. Does that make sense? That's why y has to be a value of 0. At this point, I have factored it, and I've also used a zero product property to get my x-intercepts. All right, so let's take a look at another one. And by the way, I'm using the homework that I gave to my students. So this is actual stuff that I use in the classroom, okay? All right, here we go. All right, so let's go ahead and take a look at this one that I put up here. Now, what I want you to notice is that we're missing the coefficient that's usually back here after this middle section. So the other way that I factored earlier is not gonna work in this case. But take a look at them. What you want to do is just take this right here and see if you can factor anything out. Do they have any common factors? And in this case, they do, right? So if you notice, the 2 and the 10 have 2 in common. So I know I can pull out a 2. But I also notice that each one of them has at least one x. So I can pull that out too. So what it'll look like once I pull it out, it's going to look like this. 2x, that's what I pulled out of each one, a 2 and an x. And that leaves inside an x minus 5. Equal to 0. Now, how do I know that this is correct? Because if I put it back in, it would simply be 2x times x would give me 2x squared, and 2x times negative 5 would give me negative 10x. So I know that I did it correctly. So now simply all you have to do is take the front, the 2x, because remember, this whole thing is set equal to 0, right? So I'm going to take the 2x that I factored out, and I'm going to set this equal to 0. Then I'm going to take what's inside the parentheses, x minus 5, and I'm going to set that equal to 0. So right now, just to solve this, you divide both sides by 2 to get x by itself, and x equals 0 over 2, which simply equals 0. This one right here is just a one step, and that's adding 5 to both sides. So right here, x equals 0 plus 5 is just 5, right? And don't forget, this is where your y value is going to be 0, because this is where my parabola is going to intersect the x-axis. So therefore, I have here a 0, which is my x value, but my y value is also 0. What does that mean? Yes, it's crossing the origin, right? It's intercepting right through the origin. And this one right here, 5 and 0. So on my parabola, one of the roots is crossing through the origin. The other root is crossing through 5, where the x value is 5 and my y value is 0. Those are my intercepts, my x-intercepts. All right, hopefully this is making sense to you. Let's do another example that also looks a little different and tends to throw people off. All right, so let's take a look right here. If you notice, I have 4x squared plus 8x minus 60. So it's the same process as I did earlier right here when I was doing this right here, right? But notice, if I multiply the 4 times the 60, I'm going to get a negative 240. And in the bottom, I have an 8. So I got to figure out what two numbers I can multiply to get negative 240, but also equal 8 when I add them. Okay, that might take me a bit because it's a larger number. When your coefficient right here is larger than 1, what you can do is divide everything by 4. I like to divide it by 4 when it goes in evenly into all of them, or at least the first two. It doesn't have to go in evenly into all of them. And by the way, you don't have to, listen carefully, you do not have to divide everything by your leading coefficient. You do not. I do it because it's easier, and a lot of people do it, right? A lot of mathematicians do it because it's easier this way. So that's how I'm going to get started, just to make it easier on all of us. So remember, if you're going to divide something, you have to divide everything. So I'm going to divide here by 4, and here by 4. What this is going to do simply is going to get me here x squared, because that equals 1. Now I have a 1 in front of that x squared. And then plus 8 divided by 4 is 2x. Don't forget that x. And then 60 divided by 4. Notice it's a minus 60, so I already brought down the minus sign. And 60 divided by 4 is simply 15. A lot nicer numbers, right? Smaller, so it's a bit easier to deal with. Now, if you look at here, I have a 1, so 1 times negative 15 is going to give me negative 15. So I can put that here. And then in the middle, I have a positive 2, and that positive 2 is going to go right there. Now I got to think of two numbers that I can multiply to equal 15 or negative 15, but also add up to positive 2. Now I know that 3 and 5 can be multiplied to equal 15. I have to make one of them negative. When I add them, this has to be a positive 2. So in that case, I'm going to leave the larger number as positive and the smaller as a negative. So that negative 3 times 5 gives me negative 15, and negative 3 plus 5 gives me a positive 2. So great. I just found my two numbers that I need to write in here. So x and x, remember those two x's come from my x squared. Actually, they come from here. These are the x's, 3x and 5x. And then I have a minus 3, so you write minus 3. And then this is a 5, a positive 5, so it's plus 5. At this point, I have factored my quadratic, but I want to get a final answer, which is my intercepts, my x-intercepts. So I'm going to set it equal to 0, which means x minus 3 equals 0, and x plus 5 equals 0. Therefore, x equals positive 3, and x equals negative 5. All right. So My intercept here is 3, 0. And this intercept is negative 5, 0. Those are my x-intercepts for this particular parabola. All right? I gave you 3 different types of equations. I hope you understand them. I was going to do another one, completing the square. I have another one. I gave those 4 examples. You know what? Why not? We're here already. Let's go. Here we go.
Let's do it.
So if you look at this one, let's take a look at this one. We got x squared plus 6x plus 2 equal to 0, right? Already equal to 0 because I want to use the zero product property as well. I want to factor this and get my x-intercepts. But I notice as I start to do this, oops, where's my pencil? There we go. As I start to do this, I say, okay, 1 times 2 is going to give me 2. So that 2 goes up here. And then I have 6 right here, which is my bottom number. So I say, okay, what 2 numbers can I multiply to equal 2, but also add up to 6? There are none, right? It's not going to happen. It's like, oh, shoot, I can't factor this. Not a problem. I can't factor it because that's not a perfect square. So therefore, let's complete the square. Are you ready? Let's do this. Here we go. So we're going to complete the square. This is the process. Make sure you take copious notes. I like that word, copious. Ooh, that sounds so fancy. All right, so here we go. We're going to complete the square. So this is how it works. X squared plus 6x. Now here it comes. I want you to leave this space blank. And I want you to equal, because we're going to take this positive 2 and we're going to subtract it from both sides. So move it over here. It becomes a minus 2. Okay? So here it becomes a minus 2 because I'm doing minus 2 here and minus 2 here. These cancel out, leaving me that blank spot, and this just becomes a minus 2. All right. So what do I put in here then? Simple. I want you to go to your middle number. Take this middle number and divide it by 2. I divide it by 2 and it gives me 3. That's the number that goes in there. That's going to be a positive 3. And I square it. Okay? I'm going to square it because I want to make this a perfect square, remember. Now, you know the process in algebra. Whatever you do to one side, you got to do it to the other, right? So I want to keep it balanced, basically. I don't want to change the value. So I take this 3 squared, and I'm going to place it over here along with its plus sign. And it looks like this, plus 3 squared. All right? That's what that looks like. So here, I'm just going to begin solving. Now, here, right here, notice, from here is my x. Okay? Right here, this plus sign, not this one, but this one, okay? This sign is what goes down there. So if that sign was a minus, but this was a plus, it doesn't matter. I'm focused on this sign. And this sign is going to go in here. And then I take this number here, the number being squared, which is the 3, and that's going to go in here. And then I'm going to square the whole thing. That I get this exponent from here, and that's where I get it from. So I got x plus 3 to the power of 2. Okay? Now, we're not done. We still got this part to deal with here. So we're going to set that equals, and we're going to solve this basically. This is basically negative 2 plus 9. And that right there is going to be a positive 7. So positive 7 is what goes out there. All right? Did that make sense to you? I hope it did. All right? Now, depending on what your teacher wants you to do, this could be your final answer. If all they were asking you to do is factor it, then you're done here. You have your final answer. Otherwise, you go ahead and set it equal to 0, which would just simply be x right here, x plus 3 equals 0. And this, of course, is x equals negative 3. Now, please do not set the 7 equal to 0. The 7 is just your answer there. So that would be 7 and 0 for that intercept there. And my intercept here, this intercept here of negative 3, that would be negative 3, 0. Okay, those are my 2 x-intercepts there. And that's, again, if your teacher wants you to find the x-intercepts when the equation is not a perfect square and you cannot factor it using this other method that I showed you previously. All right? Hopefully all that makes sense to you. Remember, you can always play this video again. Take notes, write this down, use those notes in the classroom when you're solving your homework and all that. And most importantly, if you got value out of this video, please hit the like and subscribe button, all right? Because I'll always be here to help you solve these and make you a straight A student. All right, you guys have a great day, and I'll see you next time on Math Quest. Goodbye.